When we have a uniform electric field that produced by these two parallel plates, first we need to know that the direction of electric field is from positive plates to the negative plates. And there is a distance between these two metal plates. How do we know which plate is positive, which plate is negative? We can refer to the terminal of the battery. This is positive terminal, so it will be positive metal plates. Meanwhile, this is negative terminal, this is negative metal plates. To find the electric field strength in between these two metal plates, we can use the equation E equal to delta V over D. E is the electric field strength between these two metal plates. This is uniform electric field, so the value of electric field strength is equal at any point in between these two metal plates. Delta V is the potential difference between two parallel plates, or also known as the battery voltage. D is the distance between two parallel plates. When we use this equation, the unit for E will be volt per meter, and the direction of E depends on the charge on each parallel plate. For example, in this diagram, the direction of E is going downwards from positive to negative metal plates. Example 3.7, calculate the electric field strength in the region between the plates. So based on this diagram, we have the battery's voltage, 300 volts. This is positive terminal, negative terminal. Thus, the positive charge will accumulate at these metal plates, and negative terminal will accumulate at these negative metal plates. The direction of E in between these two metal plates will be from positive to negative. To find E, we use E equal to delta V over D. We can't use E equal to F over Q naught or E equal to KQ over R square, because we don't have any test charge or point charge here. We only have the distance between the two plates and also the voltage of the battery. Substitute 300 volt and also 10 millimeter. Then you will get 3 times 10 to the power of 4 volt per meter. This is the magnitude. Meanwhile, this is the direction. Moving charge in a uniform electric field. When we have electric field strength between these two metal plates, we can try to put a test charge in between it. For example, I put a positive test charge in between of these two plates, and this positive test charge will attract to the negative metal plates. Thus, there will be force, attraction force, and at the same time there is acceleration. When the test charge attracted to this negative metal plates, there will be force and also acceleration. Second one, if the test charge is situated outside of the electric field strength area, what happens is it will enter to this electric field area in a straight motion, and then it will attract to the negative metal plates. Okay, here you can see that the motion is like projectile motion, so we are going to apply the equation for projectile motion later. Okay, for the first situation, we put a test charge in between these two metal plates. For example, positive test charge, it will attract to negative metal plates. There will be electrostatic force going upwards. At the same time, the test charge moves with acceleration A. Second example, we have negative test charge. When we put in between these two metal plates, it will attract to the positive metal plates, and there's also acceleration that goes downward. Consider a test charge Q0 with mass M is placed in a uniform electric field E, and the electrostatic force is given by F equal to Q0 E. Kita tak pakai F equal to K, Q1, Q2 over R square because we only have one test charge. There is no point charge here, so we can't use this equation. We have the electric field strength here, then we use this F equal to Q0 E. At the same time, when the test charge accelerates, we can find the acceleration by using F equal to MA. Thus, by using these two equations F, we can equal them, and we will get acceleration equal to Q naught E over M. Q naught is the magnitude of the test charge in between these two plates. E is the electric field strength produced by these two metal plates, and M is the mass of the test charge, either proton or electron's mass. Since the electric field is uniform in between these two plates, thus the acceleration also uniform or constant. Second situation, if we have a test charge that comes from outside of the electric field, when it enters the area of electric field, it will move with a straight line motion or on x-axis. Thus, it has initial velocity on x-axis, and then it will attract to the positive metal plates if this is negative test charge. Here we can see that it's like a projectile motion, and there is no angle right here, so we call as zero launch angle. Okay, so try to remember what are the equation for zero launch angle. We know that the motion has ux, or initial velocity on x-axis, is equal to u, where it will be constant. Uy is equal to 0. Initial velocity on y-axis equal to 0. Okay, these are the equation. If we want to find the final velocity on x component, so Vx will be equal to u, is constant value. U is also equal to ux. Final velocity on y component, how do we get this equation? It's come from the equation V equal to u plus at. Since we want to find on y component, so it will be Vy equal to uy plus at. For zero launch angle, uy is equal to 0. A is Q naught E over M times with T. Why there is negative sign right here? Because based on this diagram, the motion is going downward. So, negative kat sini. If the motion going upward, then you put positive right here. To find the resultant velocity at any point after time t, then you can substitute V equal to set Vx square plus Vy square. Sama macam nak cari resultant V. Bila you dah ada Vx, you dah ada Vy, then you can find V. We can also find the horizontal displacement as x. Sx is equal to V naught xt, or also known as uxt. So if you want to find horizontal displacement, then you need to substitute the ux and also the time taken. For vertical displacement, we can use S equal to ut plus half at square. For y-axis, Sy equal to uyt. Since the test charge move downwards, it will be negative half. A is Q naught E over M T square. We know that for zero launch angle, Uy is equal to 0. So our equation will be like this. Another thing is, tak semestinya ini sahaja equation yang you akan gunakan for this concept. What you need to do is understand the concept of zero launch angle and apply it in this electrostatic. You can also use V equal to U plus AT, V square equal to U square plus 2AS, and also S equal to UT plus half AT square. Example 3.8. In a cathode ray tube, an electron is placed in a uniform electric field of 3 times 10 to the power of Newton per coulomb. This is the value of electric field strength generated by the deflecting plates of the tube. Direction of E, or electric field, is vertically upward based on this diagram. What is the magnitude of the acceleration of the electrons? We want to find A of electron. This will be the test charge. Given E, magnitude of electrons is 1.602 times 10 to the power of negative 19 coulomb, and mass of electron is 9.11 times 10 to the power of negative 31 kilogram. To find the value of acceleration of the electron, we can use this equation. A equal to Q naught E over M. M is the mass for the electron. Then substitute the value. You will get 5.28 times 10 to the power of 15 meter per second square. Example 3.9. Electron is projected horizontally with a velocity of 2 times 10 to the power of 6 meter per second. This is Ux. And then projected horizontally means this is 0 launch angle. Pass through a uniform vertical electric field between two charged parallel plates. The separation distance between the two plates is 50 cm. This is D. The strength of E is 5 times 10 to the power of 3. If the electrons start entering the field from the top end of the negatively charged plate, electron charge or this test charge start entering this electric field from the top end, dekat hujung atas ni. Okay, so to make it more clear, saya masukkan dia start pada hujung atas. And then determine the horizontal distance. We want to find Sx when it reach the positive plates as shown in this figure. Given that mass and charge of electrons are 9.11 times 10 to the power of negative 31 kilogram and charge is 1.6 times 10 to the power of negative 19 coulomb. So we want to find Sx. The equation is equal to Uxt. We already have the Ux, but we don't have the time taken. So why don't we find the time taken using equation Sy? So Sy equal to Uyt, since it moved downward, negative half At square. So according to 0 launch angle, Uy is equal to 0. So we have half. A is Q naught E over M times with T square. So what is the value of time taken? We need to substitute Sy, Q naught, E and also M. Sy, what is the vertical displacement of this negative test charge? You can see that it enters from this point, from the top end of this metal plates, and it will attract to this end of this positive metal plate. So you can see that the Sy is right here. Daripada hujung sampai ke hujung. It's equal to 50 cm. Sama dengan jarak these two metal plates. So we put negative 50 cm. Why negative? Because the test charge moves downward. So dia punya vertical displacement is negative. Negative half. Q naught is 1.6 times 10 to the power of negative 19. E is 5 times 10 to the power of 3 divided with the mass of the electron, 9.11 times 10 to the power of negative 31 in kilogram, and T square. From here, you will get the time taken. Okay, let me show you the answer. You get time taken equal to 3.37 times 10 to the power of negative 8 second. And substitute into the equation Sx. Ux is 2 times 10 to the power of 6. Time taken is 3.37 times 10 to the power of negative 8. Then the Sx or horizontal displacement is 0.0675 meter.